This lecture is presented by John Moffat of Open Tuition. For other free lectures, visit opentuition.com.
Okay, we're going through the June 2015 paper F5 exam. Section B, and we're up to question 4. So let's have a look at the requirements. A, calculate the total variable cost per unit and total fixed overheads, 3 marks. B, calculate the optimum profit maximising selling price for the new product. And calculate the resulting profit for the period. Note if P equals A minus BX, then MR equals A minus 2BX. So 7 marks there. And immediately obvious, that's theoretical pricing. Part C, required, discuss the conditions which would make market skimming a more suitable pricing strategy and recommend whether it should adopt it. So that's our written bit for 5 marks. So let's work through. First of all, part A. It takes time to read, so 3 marks isn't very much, but appreciate the reading will be relevant for all 15 marks ultimately. ALG is launching a new innovative product onto the market and is trying to decide on the right launch price for the product. The expected life is 3 years. Given the high level of costs which have been incurred developing the product, we want to ensure it sets its price at the right level, and we've therefore consulted a market research company. The research, which relates to similar but not identical products launched by other companies, has revealed that at a price of $60, annual demand is expected to be 250,000 units. However, for every $2 increase in selling price, demand will fall by 2,000 units, and for every $2 decrease, it will increase by 2,000 units. You should realise straight away why that's relevant. It's going to be relevant for part B when we're doing our theoretical pricing. A forecast of the annual production costs which would be incurred in relation to the new product as follows. Well, for different production levels, 200, 250, 300, 350, we've got these different costs for materials, labour and for overheads, and they want to know the variable cost per unit and the fixed overheads. So, per unit, let's run down those costs. First of all, direct material. So direct material, you'd expect to be a completely variable cost, and therefore using any of the 4 levels, we can divide through. So using 200,000 production, 2.4 million total cost for 200,000 units. If we divide through, I'm scared of getting my decimal places wrong. It'd be $12 a unit. All right, I suppose in the middle of an exam, for the time it takes, I would check. It should be variable throughout, but look at the 350,000 units. 4.2 million divided by 350,000 units, it is 12. And similarly, direct labour. That should be entirely variable, so the same amount per unit, however many we produce. So just taking the first level, a total of 1.2 million for 200,000 units. Comes to what, $6 a unit? And although I shouldn't need, I must admit in the exam I would, if I check at the 350,000 level, 2.1 million divided by 350,000, again $6 a unit. Overheads, however, they're clearly not fixed. They're going to be part variable, part fixed. The requirement effectively tells us that. And so, what are we going to do? It's the high-low approach, surely. And I'm not going to give a full lecture on high-low. I'm really not. Go back to the free lectures if you need. but the variable amount, which is what we're doing at the moment, to get the variable cost per unit, take the difference in cost between the highest and lowest. So the highest 1.85 million minus the lowest 1.4 million. So the cost is 450,000 higher. The only reason it would be higher is because of the variable cost of the extra units. So the extra units, the high one was 350,000, the low one was 200,000. So the variable cost of the extra 150,000 units is the 450,000 at the top. So the variable cost went up by 450,000, the units went up by 150,000. The variable cost is $3 a unit. So the total variable cost, $12, $18, $21. So that's part of part A. They also want to know the fixed cost. Well, the fixed overheads. Take any of the levels. If we take 200,000, the total cost is 1.4 million. We know how much variable is included. The variable 200,000 at $3. So it includes a variable cost of 600,000, which leaves the fixed cost, the fixed overheads, at 800,000. I'm not going to check, but I can check actually, I can do it in my head. If you want to double check, look at 350,000. That total should be variable 350 at $3, 1.05 million, plus 800,000 fixed. It does indeed come to 1.85 million. So that's part A. What about part B? Well, standard theoretical pricing, it really is. First of all, we've got to get the price-demand equation, relating the price per unit P to the demand in units X. B, you've got your formula sheet, but the B is the change in price over the change in demand. For every $2 increase in price, the demand falls by 2,000 units. And so B, 2 divided by 2,000, is 0.001. Do be careful of your decimal places and make a huge difference. A is the maximum selling price when the demand is 0. Well, to calculate A, take whatever the current price is, or the one that's given, which what? 1, 2, 3, 4, and the fifth line of the question, 60. If we had a price of 60, demand would be 250,000 units. For demand to be 0, it's going to have to be higher. Well, it's higher by B times the expected demand. So 0.001 times 250,000 gives A the maximum selling price as being I hope I'm right, I get 310. And so the price-demand equation is P is 310A minus 0.001 times the demand. We don't need it for the moment, we will later, but we still needed the workings because for the profit maximising for the optimal selling price, if you remember, marginal revenue, it occurs when marginal revenue equals marginal cost. Well, the formula for the marginal revenue, MR, you're given, you always would be given. It's A minus 2BX, A and B, what we calculated before. So A is 310. 2 times B, well, B was 0.001, so 0.002x. I said a moment ago, for optimal selling price, marginal revenue is equals marginal cost. Well, the marginal cost, all right, MC, marginal variable cost, and we've already worked out the variable cost per unit. What did I get earlier? In part A, 21. Incidentally, while I'm here, you don't lose marks twice in the exam, so although you should have got part A right, it wasn't hard. If you had done something silly and got 25 or something, well, you'd have got full marks for part B if you'd have done it correctly on your figure from part A. So don't worry about losing marks twice, provided that the marker can see what you're doing. That's why it's so important to be neat. Sorry going on here, but, you know, even if you found part A really easy, in the middle of an exam, you're never going to be 100% certain you haven't done something wrong. If that 21 was wrong, this is wrong. Oh, sorry. This is wrong. But I say again, because it's clear what I'm doing, I've set out the workings neatly, I'd still be getting full marks for part B. Anyway, let's finish part B. For maximum profit, marginal revenue equals marginal cost. So 310 minus 0.002x equals 21. If you've not practiced algebra, you better practice. You can't afford to waste time here. 0.002x is 310 minus 21, which is 289. And therefore x is 289 divided by 0.002. 144,500. We're not there yet, remember, because although I know how many units we need to sell, we are actually asked for the selling price per unit. And so to get the selling price, we need to go back to the price-demand equation we had earlier. The price per unit is 310 minus 0.001 times the demand. Well, we've worked out the demand will be 144,500. Therefore, it'll be 310 minus 0.001 times 144,500, 144.50, which gives 165.50 per unit. Unfortunately, we're still not there for part B. We've done the first bit, calculate the optimum selling price, 165.50, but also calculate the resulting profit for the period. Well, you can get the profit several ways. I'm not going to mess around here, but you get it several ways, but clearly speed matters, the faster the better. And what I would do, as in fact I do a very similar example in the lecture on pricing, I'd say, well, the total contribution, we're selling 144,500 units. The contribution per unit is the selling price, 165.50, minus the variable costs. The variable costs, I better check, I think they were 21. Oh, good heavens. Yes. So the contribution is 20880,250. But that's the contribution. For the profit, we need to subtract the fixed overheads. We worked them out earlier. They were 800,000. And therefore, the maximum profit is 20,080,250. Which does seem huge, but it's correct. Finally, what about C? Now, as always, I'm not going to write a full answer. I keep saying every time you must read the examiner's answer and learn from it. But, yet again, not to have written anything for Part C would have been awful, even if you ended up not quite finishing Part A or Part B. Because there's 1 or 2 marks here which are desperately easy. Discuss the conditions which would make market skimming a more suitable pricing strategy for ALG. Now, don't waste time defining market skimming. The question effectively is defined it for you. Sales director is unconvinced that the sales price is the right one to charge on the initial launch of a product. He believes that a high price should be charged at launch, so that those customers prepared to pay a high price can be skimmed off first. You charge a high price at the beginning. Rich people pay it, and then you can drop the price to attract more customers. But again, you weren't asked for a definition. That would be wasting time. But the conditions and the recommendation, look at the first bit of the first paragraph. We're launching a new innovative product. Well, certainly, new and innovative are 2 conditions, if that's the right word, to make market skimming sensible. It doesn't work if there are already lots of similar products. Why should anybody pay a high price? It's where you're what you might call exclusive. What else does it say? The expected life is 3 years. It's got a short life. Again, for market skimming to be an attractive idea, it becomes more attractive when it's a short life product. High development costs. Again, by charging a high price early, we want to try and recover the development costs as fast as we can, especially because it has only a short life. What about whether we'd recommend they should adopt the approach? Well, from what I've said, those things do apply to this product. And so in that sense, it would seem a sensible thing to consider. The only thing, all the arithmetic we've done, it really depends on the accuracy of our calculations. You know, it's a similar but not identical product launched by other companies. Well, does that $60 actually mean anything? That's the problem. Now, in the exam, don't just write 2-word answers like that. Write sentences. I always think it's hard to get 5 out of 5 to get full marks on a written. But you can get a few marks there very easily and very quickly. Not to have done anything is desperately dangerous.